All right, in this lesson we are going to talk about finding the angle measures in any shape. And so here's my question for you. It's, what did the mathematician say when her parrot flew out the window? You've guessed it, polygon. Polygon is just a shape. A circle is not a polygon. It has to be a multi-sided figure. So a circle only has one side, and we're going to learn about circles after this whole chapter. If you look over here, you'll see all the other stuff that we have to go ahead and learn before we do circles. So let's just talk very quickly about a convex versus a concave polygon. A convex polygon does not cave in. You can remember concave, or we might talk about concavity, because it caves into itself. So all of these are showing concavity. This is convex, and there it is. The diagonal of a polygon is a line segment that starts at one vertice and goes to the other one. Okay? Now, if we were in class, what we would do is I would go through all of this. We would talk about a triangle has 180, but I'm going to do this kind of quickly because nobody's going to be guessing the formula. I'm just going to tell you. So we all know a triangle has 180 degrees in it. Okay? So if I had one triangle, how many triangles would there be? One. So it would have 180 degrees inside. Now, if I draw diagonals, and I'm not going to draw all possible diagonals, I'm just going to pick one vertex and draw as many diagonals as possible. You'll see that I get two triangles, and each of these two triangles are worth 180. And so a four-sided figure has 360 degrees inside of it. Okay? A five-sided figure, and we will go over the names for all of these. If I pick one vertex, I can't draw any more triangles. You now have three triangles, each at 180, which gives you 540. Six-sided figure, pick one vertex, boom, boom, boom. You get 1, 2, 3, 4 triangles at 180. What does this have? 7? 1, 2, 3, 4. 1, 2, 3, 4, 5 triangles at 180. What is that? 1080. 8-sided. Boom, 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 boom. You get 6 at 180. Oh, I lied about the other one. Hold on. This should have been 900. Whoopsies. And then this one is 1080. Okay. You should remember these shapes from probably elementary school. I know you want to say that this is a square. For our purposes right now, it's not. It's just a quadrilateral. Hence the term quad. Five-sided is a pentagon. You have a hexagon. Here's a heptagon. An 8-sided is an octagon. A 9-sided is a nonagon. 10-sided is a decagon. 11 is an undecagon. 12 is a dodecagon. And really any other shapes after this, you're just going to say it's a 432. That's a Z. Great. A 432 gon. So at a certain point, you don't really need to give it a prefix. Okay? Now, if you look at all of these triangles, you'll notice that it had 3 sides and 1 triangle. 4 sides, 2 triangles. 5, 3, 6, 4, 7, 5. So you'll notice that the number of triangles is going to always be 2 less than the number of sides. And since each one of the triangles is equal to 180, you take the total number of triangles and multiply it by 180. And so this is the formula for you to find the number of interior degrees inside any polygon. It's n minus 2. This goes in parentheses because you're going to do it first, times 180. So let's say we had a decagon. The number of triangles that exist is 8. And then 8 times 180 is 1440. Okay. One more vocabulary word, and that is the word regular. Regular means that all sides and angles are congruent. So find the sum of the interior angles of a regular convex 82gon. Okay, 82 sides minus the pattern tells me that there are 80 triangles and they are each worth 180. And so the number of interior degrees total is 14,400. If I wanted to find the number of degrees in each angle, because now be careful, there's 82. You have to go back to this original problem. Okay. If I want to find the number of degrees in each angle, because it is regular, I can divide it by the number of sides or angles. You'll get a decimal. It's okay. 175.61. Okay. And then, of course, there's going to be some where we work backwards. So it says the sum of the measures of the interior angles of a convex polygon is 2520. Classify the polygon by the number of sides. So it's saying that when somebody did this formula, they got an answer of 2520. Now, I know that we could distribute the 180 to both of these, but then you're going to wind up dividing it out anyway. So what I'm going to do is right away divide both sides by 180. That gives me 14. This is, if you're going to get the question wrong, this is what's going to happen. You're going to say the answer is 14. It is not 14. It is also not 12. The answer is 16. So it is a 16 gon. Okay, so that's how you're doing the interior. Okay, for the exterior, let's just say for a second I had a square or a quadrilateral. Well, in this case, let's make it a square. And that's what we're moving on to this week, is all of the quadrilaterals. If I had a square, each one of these angles would be 90. And so then each one of its supplements would be 90. And so all of these exterior angles would be 90. I'd have 4 90s, and that would equal 360. Okay, here's a pentagon. A pentagon is 540. If I divide that evenly, each one of these winds up being 108. And if I find the supplement of 108, I can see that all of these exterior angles will be 72. And if I multiply 72 times 5, all of the exterior angles of the pentagon total 360. Now, I could sit here and do this for all of the other shapes, or you could just believe me when I tell you that no matter how many sides the polygon has, the sum of the exterior angles has to equal 360. So I'm not going to do all of this, but you do need to know that the sum of all of the exterior angles equals 360, no matter what the shape is. Okay? If it said you have an octagon, remember an octagon has 8 sides, so it would have 1,080 degrees inside of it. If I divide this by 8, if it was regular, there would be 135 degrees inside each angle, which means that there would be 45 degrees in each exterior angle. If I multiply this times 8, I get 360. So if you just remember that this is 360, that is the magic number on the outside, you can just divide it by the number of angles and just get your answer instead of doing all of this work. Okay? Let's see, what other ones do I want to do on here? So I'm going to do a few of these, and then I'm going to leave the rest of them for the Go Formative. All right, so this tells you what the measure of the exterior angle is. Okay, so this is all exterior. So if one angle is 30, it wants to know how many sides it has. Well, if one angle is 30, it has to have 12 sides. So all you're doing for the exterior is using that 360. So it's going to be the same thing for 2 and 3. Okay, first thing it's telling you is that it's a pentagon. You will start to remember the numbers, but if you don't, do the formula. If not, a pentagon is 540. So it's telling you that the measures of on the inside of the pentagon are these 5 expressions. So just like we used to do with triangles, just do the same thing. I'm going to just add these all together in my head. 2 plus 2 is 4, 5, 6, 10. And then my constants are positive 45 minus 3 minus 132. So negative 90. And then you're just solving a two-step equation. So 540 and 90 is 630 equals 10x. That means x equals 63. So we found out what x equals. It does want to know if it's regular. So to tell if it's regular, all the angles would have to be the same. So let's see, 263s. I don't know why I'm using a calculator. So it would be 126, 126. And then this would be 108. So you can see right away that it's not going to work. That's 60. It's something else. 120. So it's not regular, but remember, a pentagon doesn't have to be what you're thinking of. It can be any shape that's 5 sides. It could look like this. That's a pentagon. It has 5 sides. Okay. What is the sum of the measures of the exterior angles? Well, easy. It's 360. It's not regular, so we're not going to divide this 360 by 5 because all of these angles are different, so they'd all have different supplements. So make sure you're reading if it says regular or non-regular. The measure of the interior angle of a regular polygon is 157.5. Find the number of sides of the polygon. So again, somebody did this formula. Now, when we did the formula up here, so like for this one, I did this formula, and then I divided by the number of sides, and that told me how many degrees was in one angle. So when you're working backwards, it's important to read what the question's asking for. If it just told you what the sum of all of the angles are, then you would just put the sum here and solve it like we did this one. But it's not telling you what the total sum is. It's telling you what the measure of each angle is. And in order to get that number, you have to divide this by the number of sides. And when you do that, it will be 157.5. So let's just recap real quick. This tells you how many degrees are in the whole entire shape. When you divide by the number of angles or the number of sides, that will tell you how many degrees are in each angle. So if you do not set it up like this, you're going to be in a little bit of a pickle. Hopefully if you set it up and got this far, you'll remember how to solve this. And that's by multiplying this side by n, which would cause these n's to become 1. And then multiplying by n over here. So now you're left with this. Now, I could divide by 180 again. I'm not going to. And I'm not going to because this would not simplify. If it was like 360n, then 100% I would divide by 180 and simplify it. But if I divide by 180, it's going to be a little bit more messy than I would like to deal with. So you can, but I'm going to distribute the 180. So now if I do this, I'm going to just take away 180 from that side. And so I'm left with 360 on the left equals 22.5 n. And then you're just going to divide 360 by 22.5. And you get that n, or the number of sides, is 16. Okay, whatever ones I did not do on here, I'm going to put on the Go Formative just for you to do a quick check, and then I will put up maybe I'll do a quizzes. So let me know if you have questions on this. There's just 3 questions left. So work on those, and then, like I said, go to the quizzes.